All right, welcome to our continuation of part one, our warm-up with the ideal gas law and Dalton's law of partial pressures for our lecture video series on Friday, May 5th. So we just answered what the partial pressures of each of our gases were, or what their new pressures were after we opened that two-bulb system and let the gases fully mix. And now we want to know what the new total pressure is in the bulbs after mixing. And there's a couple of different ways we can do this. So the first is by recalling that since we're looking at a total pressure, this means that we're looking at Dalton's law of partial pressures, which says that the total pressure in the bulb is going to be the sum of the pressure from the helium gas and the sum of the pressure of the hydrogen gas. And this is these pressures, sum of the pressures of our gases after they have mixed. So we can't just take their initial pressures and add them. We want the total pressure post-mixing, so we need to know what these partial pressures were pre-mixing. And luckily for us, we just solved for these pressures right up here in part A. So this is 0.5398 atmospheres of helium plus 0.7890 atmospheres of hydrogen. This gives us a total pressure of, let's see what that addition is, 0.7890 plus 0.5398 gives me 1.3288 atmospheres. And then, of course, for the correct sig figs, let's assume that our volume had 2 sig figs. This becomes 1.3 atmospheres is our total pressure after mixing. All right. Now, there was another way you could do this. The other way that you could do this was by thinking about what's going on in our system, like if you want to reuse the ideal gas law. So we could say that the total pressure times the total volume over the total moles times the new temperature is equal to R. So this is kind of like an alternate option. If we wanted to rearrange for total pressure, this would become total moles. This should be total. Total moles of gas times R times T over total volume, where N total is going to be the sum of the moles of hydrogen and the moles of helium. And let's do helium and hydrogen just because I've done all my helium stuff on the left and hydrogen stuff on the right. So if I scroll back up through our work in part A, I have these mole quantities. So for helium, 0.11220. Moles of helium. And then for hydrogen, we had 0.16411 moles. Totally forgot that number as I said it, 16411. So the total moles in the new open bulb, which is the same as the moles originally, it's just they were separated from one another. So 0.1122 plus 0.16411. This gives me 0.27631 moles of gas in total. So let's see that this second method, or if this method, agrees with what we got using Dalton's law of partial pressures. So the total pressure would be equal to the total moles, 0.27631 moles of gas, times R, 0.08206 liter atmospheres per mole Kelvin, latim per molk. Again, that's how I remember those units. Times our temperature, this was unchanging, to 93.15 Kelvin, over now the total new volume of 5.0 liters. So this should agree with what we got. Let's see if it does. So 0.27631 moles times 0.08206 liter atmosphere per mole Kelvin times 293.15. All right, then divide that by 5. I get 1.329 atmospheres, which to 2 sig figs is 1.3 atmospheres. Lo and behold, this agrees with this. So yay. Okay, so my advice for you is anytime you're trying to tackle just these like kind of ideal gas law equations where you have maybe some changing variable like a changing volume, or you have a changing variable like a changing temperature, is to kind of go back like we did up here and identify what is changing and what that's going to affect. So we said that volume is changing, which means pressure must change. And then we need to identify kind of what's remaining the same. And then we need to think about what information do we need in order to understand what's going on in that change. So for us, the information that was needed was the moles of gas, which is why that was where we started. I think let's do another warm-up example. So let's listen to the third part. So let's do the ideal gas law practice coming up in our next video. So see you then.